Welcome to The Explainer. So, for the last few years, we've all been watching AI do some pretty wild stuff, right? Writing code, drafting our emails, generating crazy art. But all of that massive intelligence has basically been trapped inside our devices. Well, today, that intelligence is actually breaking out into the physical world, and the race to build this absolute next frontier of technology is officially on.
Listen to this. AI is escaping the computer screen, and Japan wants to give it a physical body. That's the quote. And guys, this isn't science fiction anymore. It's a highly coordinated, incredibly well-funded engineering effort happening right this second, and it's literally going to fundamentally redefine what the next decade of our reality looks like.
All right, Section 1, Escaping the Computer Screen. We are moving straight from the digital realm right into tangible reality.
Which brings us to Section 2, the Physical AI Challenge. Okay, let's dive into this, because the hurdles engineers are facing here are just massive. There is a huge fundamental difference between the AI we know and the AI that's coming. Think about it. Software AI and chatbots operate in totally predictable text-based environments. If a chatbot makes a mistake, you just get a weird, clunky sentence. But physical AI, it has to perceive, reason, and act all at the exact same time. It's taking in sensory data from a totally chaotic environment, making a split-second decision, and physically executing a mechanical action. The leap in complexity here is just staggering.
And because of that wild complexity, traditional robots really deeply struggle with unpredictable objects and chaotic real-world environments. Look, in a traditional factory, a robot is programmed to repeat the exact same millimeter-perfect motion maybe 1,000 times an hour. But our daily world? It's not a controlled factory floor. Lighting changes, objects get dropped, people randomly walk in the way. If a rigidly programmed robot encounters something unexpected, it just freezes, or honestly, worse, it breaks something.
So how do engineers actually solve this unpredictability problem? Well, they use digital twins. To teach an AI how to navigate total chaos, you can't exactly put a multi-million-dollar prototype in a room and just let it blindly bump into walls. Instead, engineers build virtual, highly accurate simulations of real-world environments. They basically let the AI practice, fail, and learn literally millions of times inside this totally harmless virtual space before it ever takes a single step in a physical body. It's kind of like a flight simulator, but for a robot's brain. Moving on to Section 3, Japan and NVIDIA team up. This is where we see exactly how they're planning to tackle these massive challenges.
This partnership is essentially the perfect marriage of two completely distinct specialties. On one side, we have NVIDIA, right? They're supplying the absolute cutting-edge AI computing technology, the silicon brains capable of actually running those complex simulations and processing sensory data in real time. And on the other side, major Japanese robotics companies like Fanuc and Yaskawa Electric are bringing generations of deep manufacturing experience. You just can't have physical AI without world-class physical bodies, and that is exactly what this collaboration delivers.
We seriously cannot overstate Japan's role here. Their unmatched historical experience in manufacturing makes them the absolute crucial hardware partner for physical AI. They have spent decades perfecting factory automation, precision engineering, and mechatronics. The best way to look at it? While Silicon Valley has spent the last 40 years mastering software, Japan has mastered moving atoms.
Look at this number for a second, 27,500. That is the precise number of highly advanced NVIDIA Rubin chips that Japan-backed Noetra actually plans to acquire. And for those keeping track at home, Rubin is NVIDIA's next-generation architecture. The sheer scale of computing power this represents is immense. It proves that this isn't just some fun, experimental research project. No, this is an aggressive, highly capitalized move to dominate the entire future of physical AI.
Section 4. Real-world AI applications. Let's talk about where we are actually going to see these robots in our daily lives. The target industries for this technology are set to completely revolutionize the fabric of our daily routines. First up, factories, where we'll see adaptable robots that don't just repeat motions, but actively problem-solve right on the assembly line. Second, hospitals. Just imagine AI assistants that can physically help nurses lift patients or perfectly transport sensitive medical supplies through incredibly crowded corridors. Third, logistics. We're talking about transforming supply chains with machines that can seamlessly load, unload, and navigate totally dynamic warehouses. And finally, homes. The ultimate goal here is an AI capable of understanding the absolute chaotic environment of a living room to help out with elder care or just daily chores.
So the crucial point is, we need to talk about the reality of this. Section 5, Hype, Limitations and Concerns.
Let's be clear, we are still firmly in the developmental phase here. There is currently no firm timeline for everyday consumer deployment, and to be honest, absolutely no concrete proof yet that general-purpose robots are fully ready to safely navigate the messy, highly unpredictable real world outside of those digital twins and controlled lab environments.
Furthermore, the source material points out 4 massive, core societal and technological concerns that definitely need to be addressed. First up is reliability. Can a physical AI actually operate for years without breaking down? Second is safety. How do we guarantee a heavy, powerful robot won't accidentally harm a human in a chaotic environment? Third, employment changes. What happens to the labor market when robots can perceive and reason just as well as human workers? And finally, energy demand. Running highly advanced AI chips like the NVIDIA Rubin requires just vast amounts of electricity, which raises some really serious questions about the strain on our power grids. These are monumental challenges that both NVIDIA and Japan will have to navigate very carefully.
Which ultimately leaves us with one incredibly vital question. Will physical AI become as important as smartphones, or is the technology being overhyped? The brains are built, the bodies are being manufactured right now, but only time will tell if they can truly conquer our chaotic reality. Thanks so much for joining this explainer, keep questioning the future, and I will see you next time.